Awesome. Okay, so welcome back. Day 2 of calculus. Day 2 of limits. We'll be hanging out. Like I said, chapter 1 is basically all kind of using limits and understanding them. So now's a really good time. Is there anything from yesterday that I can clarify now before we try to put it into action? Is there anything about the notation or the words? Or like we ended with that, right? The actual limit existence theorem. If I want a limit to exist, I want it to be a real number, but if I want that to happen, and you can see like this is just like as x approaches some number, right? C is just a constant. I want the limit from the left side and the limit from the right side to just be the same. Like we did with that 7/6 spot, if you can remember that from yesterday. Right? As we approach -3 from the left, as we approach it from the right, we were both heading towards the same y value, which meant that limit existed. The other ones, one of them was just a one-sided limit going towards -infinity. One was just a one-sided limit going towards positive infinity. And then, of course, we were just talking about, that vertical asymptote, and that one does not exist. With the one-sided limits, sure, we'll say infinity or we'll say -infinity just to tell a slightly better story, but that's not a real number. So the truth is those limits don't exist. We can just say infinity if it makes us feel a little bit better about what direction things are heading, only for one-sided limits. So hopefully that's okay. Any questions? Or we want to kind of put it in action, see what we get. Put it in action. Okay, cool. So let's do it. So here we are, page 15. So at the top there is that limit existence theorem, which we wrote down last time. And like I just said, the big idea is that if I want my limit to exist, it has to approach the same y value from both sides. Okay, and that's what we're going to do. We're going to see what happens when we look at kind of a collection of possibilities for when limits do exist and when they don't, and kind of recognizing what that looks like visually. And if we can recognize it visually, because the graph I think is the easiest way because I can just look at it and see what's happening, then we can look at it numerically, which we will on page 16, and we can start to look at it analytically, just kind of looking at a function without the graph, without the table, and trying to figure out, okay, is this limit going to exist or not? And how do we do that, right? So we'll kind of build up to that here in the next couple of days. So I'm going to scroll down, which means I'm going to get rid of what's up there so that we can start talking a little bit about this first example, okay? And I want to walk through them with you just because this is kind of our first time doing this. Although if you felt like yesterday went really well, you might be able to do this on your own. So if you want to work through it a little bit faster than me, great. But if you want to make sure that you've got a pretty good understanding, we can talk through it together as we go, okay? And so looking here at example 1, they give us a graph of some function. And there's that notation, right? And I would love for you to know how to say this well, okay? The limit of f of x as x approaches 2 from the left. All right, being able to read the notation in calculus is going to play a really big role in your success. And so for me, okay, so I'm approaching, and so you can this is how I think about it. I'm approaching 2 from the left. And if I want to understand the limit, I want to follow the function as it does that. That's kind of like the feeling that I have is I get myself pointing towards an x value, but I give myself some space to do that, right? Calculus happens in motion, and then I move myself along the function to see where I'm headed. And because this is a one-sided limit, I think we're okay here to say infinity, okay? You are also absolutely okay, and I would never take off points for you saying the right thing, to instead. So this is not both. This is an instead of kind of scenario. You could instead say that the limit does not exist. Why? Because we're not headed towards an actual number, right? We're headed up or down forever. Okay, so either one I think is fine. I like the red one for one-sided limits just because it just, like I said, tells a better story, okay? So hopefully that makes sense. And you're like, oh yeah, I get that. That feels right to me. Okay, same thing for B, except we're going to approach 2 from the right. So that's kind of the feeling that I have to start as I look at what x value we're approaching. And if you want a limit, if they're asking us for a limit, then I follow the function as I do that, as I move towards +2. And you can see I'm never actually getting there, right? It doesn't matter. And of course, that limit, of course, also infinity, which is okay to say if you want, or you are absolutely allowed to. In fact, there are, I would say, plenty of calculus professors that would say, no, that limit does not exist, and that's the one and only right answer, and that's okay too. There you go. There's our two limit questions to get us started, our one-sided limit questions, okay? There's an in-between question that just kind of backs us up a little bit to our understanding of the difference between evaluating a function, right? Like saying f of 2, evaluate f of 2, versus evaluating a limit, right? Finding the limit as we approach a certain value. Okay, kind of two different ideas there, right? And when we look at f of 2, trying to see what y value we're supposed to get back, we see a vertical asymptote. And so the big difference that I want to make sure is clear is that functions can be defined or not, right, if there's a point there. Limits can exist or not. So I don't want to say does not exist right here for f of 2, right? We want to say undefined. Because there's no point there, obviously, right? We either have a hole or an asymptote, that function is going to be undefined. Okay. And so I want to open this now up to you, now that we've kind of talked through those first three. What do you think about D? Do you think that that limit of f of x as x approaches 2, and so you see there's no little minus, there's no little plus, that means from both sides. Does that limit exist or not, and why? I'd love to hear from you guys. Do you have any thoughts as to whether or not that limit exists?
It doesn't exist because it's not a real number.
Does not exist because what?
It's not a real number.
Yeah, we're not approaching an actual real number. The limit from the left and the limit from the right are not equal to a real number. So I would say maybe, okay, so it does not exist because, in little b/c, just to use some shorthand, because the one-sided limits do not approach the same real number. That sounds good. That do not approach the same real number. And of course, neither of them are even approaching a real number to begin with. But this really kind of covers ourselves because that's what makes a limit exist or not, whether or not it's approaching a real number. Cool. So there you go. How do you feel? Talk to me, look at me, give me some, okay, still a little shaky, some of us? Okay, so let's keep going. Let's do some things together, make sure we're feeling it, because I want you to see kind of the difference between examples and the kind of things that are gonna happen that we wanna look at. Because what we're building up to, remember this chapter really as a whole is called limits and continuity. And so we want to kind of build up to an understanding of what continuity or the lack thereof kind of does with limits. Okay, let's do another one. I like it. Okay, so they want us to go to 2 again, so that's kind of nice. So as we approach 2, and part A has that little negative, so that's from the negative side of the graph. So in my mind, I'm kind of like going like this. And I'm approaching 2 from the left. And to do that, I follow the function as I get closer and closer and closer to it. And so remember, the question here is, like, when we're talking about limits, is what y value we're getting close to. Limit doesn't care about the actual point itself. Limit just cares about what we're getting closer and closer and closer and closer to. And so what do you think? What y value does it seem like we're approaching as we approach x equals 2 from the left?
2.
Yeah, absolutely, right? This y value at that spot looks like 2. And when it's not exactly perfect, you can assume the nicest version of that number. You know, maybe you think the hole is like a little bit below 2, don't sweat it. It's just printing and imperfection, so it's all good. Okay, now I do the same thing, but from the other side, right? Little minus means from the left, little plus means from the right. So I'm coming this way. Right? That's kind of my thinking. So I'm going to approach it from the right, but I want to follow the function as I do. So what y value are we getting really, really close to? And you can just drop it in the chat. You don't always have to unmute yourself to say it if that's faster, easier.
2.
Yeah, 2. Right? It's the same spot. We're approaching the same location from both sides. Okay. And so let me skip C just for a second. Look down at part D. Does the limit of f of x as x approaches 2, and look, no minus, no plus, that means from both sides, does that limit exist or not, and why or why not?
It does exist because it's the same number from both the positive and the negative side.
Perfect. And the nice way to say that is you can just kind of like copy, say, what you said and just use limit notation. That, not C, we actually have a number, so I got it. Formula mode there. The limit from the left is equal to the limit of f of x as x approaches 2 from the right. They are exactly the same. And of course, you can say that in words too, just like you said. Yes, because they are both approaching the same number from the left and from the right. That would be a great way to say that, which is exactly what I just said, but just in calculus notation. All right, so that limit of f of x as x approaches 2 is 2, because they're both headed towards the same spot. But what is f of 2? Like, you plug in 2 for x, f of 2 is supposed to give me the y value of the point where actually, like, the point actually is for the function. Where is that? Like, where is f of 2? Is it 2? Is that where the actual point is on the function? Oh, we have a hole at 2. It's not undefined because there is an actual point down here at -3. And so you can see that although the limit from the left is 2, the limit from the right is 2, which means that the limit is 2. The limit doesn't care about where the actual location of the point is. And when you have a hole like this, the limit is definitely going to exist as long as we're approaching that same hole from both sides. And if this point wasn't here, okay, then f of 2 is undefined, just kind of like it was for the last one, right? There's no point at that spot. But if the point is there, the value of like the actual function can be somewhere else, but the limit can still exist, okay? And so that's a big, big kind of thing that we want to make sure we're okay with seeing the difference between evaluating a limit and just evaluating the function. Okay? Limit does not care about the actual point. The function does, right? F of 2 means where's the y value? Go to the point where this y value exists. Okay, cool. Stop me if you need me. I'm going to scroll. Let's do this last one together. Because why not? We might learn a little bit. Okay. Definitely some disconnection here, and we've seen a lot of discontinuity in all three of these, right? One was an asymptote, one was a hole, right? And this one, we're just kind of, you know, we've got these two kind of broken pieces. So this function is just kind of piecewise somewhere, right? I'm sure there's some kind of formula we could figure out for this. But we have the graph, which makes it a whole lot easier to evaluate limits because we can just look at it. And so let's do it. Let's evaluate that first limit as x approaches, they pick 2 again, from the left. So I'm coming this way. And you can see that I give myself some space to do that, right? I'm not like super, super close, but I do want to get super, super close. And I just follow the function to do that. But I never actually get there. And that's okay, but I still just want to think about what y value am I getting close to. Whether the point is there or not doesn't make a difference. It's what y value am I approaching. So what do you think? What is that magical y value that we're getting closer and closer and closer to?
3.
Perfect, right? That's what we're getting close to. I like it. And we can do the same thing from the right. And as I approach 2 from the right, I'm going to try to do that, but I'm going to follow the function as I go. And so when you have these one-sided limits, it's like the other side doesn't exist. I don't care about what's happening on one side versus the other if I'm just looking at a one-sided limit. And so when I take that blue route towards 2, I'm going to follow the function down towards a very different spot, right? And we're headed towards, and I hope you can see that, right? -3, not +3. And so what do you think? Skipping C for now, because I want to talk about limits. What do you think? Does that limit of f of x as x approaches 2, and I don't even have to say from both sides. If I don't say from the left or from the right, I mean from both sides. Does that limit exist or not?
No.
Because?
They're different points.
What do you mean?
Like when x approaches positive from the positive side, it arrives at -3.
Okay.
And when x approaches from the negative side, it arrives at +3.
Good. So we are approaching different values from either side. Good. The limit from the left side is just not the same as the limit from the right side. And there's a lot of different ways you can say that and be true. And I think we just kind of covered a few of them, right? And you can write it in symbols like we did last time, or you can just write it in words, because the limit from the left is not the same, is different, is not equal to, whatever you want to say, is, what should I say? Is, I don't know, is not equal to. Sure, that's a good one. The limit from the right. And feel free to say it in the way that makes the most sense for you, that really ties in the direction that you're coming from one side versus the other, and us approaching different values. So however you want to say that, I'm cool with. You can kind of get comfortable with all of it. Okay? All right, so we saw 3 discontinuous graphs, right? Where 2 of them, the limit did not exist at a certain spot, but one of them did. Okay, and so continuity is not critical for limits to exist. And I think that's kind of the big takeaway here. Although it would be really nice, right? If things were nice and continuous, because then I would approach the same value from the left, the same value from the right, and the point would just be sitting there, right? That's really nice. We love continuity because then limits exist and the value of the function is the same as the limit, and that'll kind of build up to what we're going to get to. Chapter 2, which is super nice, and even second half of chapter 1. But you know, like the value of the point here for C, well, sure, like the actual point is up at +3, right? Because that's the part that's circled in. So the limit from the left is the same as the value of the point as we get there. The limit from the right's different. Okay, and so that means the limit doesn't exist. And if the limit doesn't exist at that point, there can't be continuity, right? We have to be approaching the same value from both sides if we want to even have a chance at continuity. So something we're hoping to build up to for sure. So hopefully that kind of talking through that helped. I want to give you a chance to actually try some of these things on your own. So although page 16 would be next, well, maybe we'll just kind of fill in the top part. We'll kind of talk that through. I want to skip the tables for now, and then we'll eventually flip to page 17. But go to page 16 so we can kind of, I don't know, conclude what we just kind of saw and see what we can think about in terms of kind of what they're asking. So based on what you've seen so far, does f of A, so just some number, right? Sometimes we use C, sometimes, any letter at the beginning of the alphabet is good for unknown constants. Does f of A have to be defined in order for the limit to exist? So does there have to be an actual y value at that number in order for the limit to exist as we approach that x value? Let's just answer that first before we move on. What do you think? Does the function have to actually have a y value at a point for the limit to exist at that point?
No, because you could have a hole and the limit would still go to a different point.
Imagine that one, right? The one I was just talking about. Like if that point wasn't there, it doesn't change anything about our calculus limit, right? It changes obviously f of 2 from being -3 to being undefined, for sure. Big difference there for the value of the function. But we don't have to actually have f of a be defined for that limit to exist. So to answer that first question, does f of a have to be defined? No. F of a could be undefined. And the limit of f of x as x approaches a could still exist. It could be undefined. Now, it's nice if it is, but it doesn't have to be. Okay, and so what I'd love you to actually try before I just go through it, it asks us to try drawing two different kinds of graphs. Okay, they're going to be relatively similar in spots, and I want to give you a chance to just kind of draw them on your own. So draw and explain. I think the graphs will be enough explanation for me. Two different kinds of graphs. So I want you to like come over here like a little very simple set of axes, whatever you want, okay? With this one, the limit does not exist. Okay, and over here, let's make the limit exist. And that's very informal notation, just saying LIM. Exists. And I want you to say, okay, like, so kind of draw this with me, like, here's A right here. Here's A right here, some constant along the way. On the graph on the left, I want you to draw it so that the limit doesn't exist and f of a is undefined. So there's no point at that spot. However you want to draw that, it's up to you. Same thing on the right, but the limit does exist. Draw any kind of graph that you want. Simple. Keep it really simple. Graph on the left, A is undefined. Graph on the right, f of a is undefined. So no points there at all. But the graph on the left, see if you could draw a sketch of a graph where the limit doesn't exist at that spot for whatever reason, okay? With the graph on the right, draw something where f of a is still undefined, but the limit does exist. Okay, take a minute, think about it, and see if you can draw a very simple sketch of a graph where it's undefined for both, and the limit does not exist on the left, and the limit does exist on the right. Give that a shot. All right, who's got an idea for either one? I think the one on the right is probably a little easier because we just kind of talked about what that could look like, but I want to hear from you. What does your graph look like for one or the other? Even if it's wrong, who cares? We'll fix it. Describe one of your graphs.
Vertical asymptote on the left.
So on this one, we've got a vertical asymptote. Okay, so I could draw that vertical asymptote there. And then, so what does the graph look like as it approaches that vertical asymptote, let's say from the left?
It goes up over the horizontal asymptote.
Okay, so something like that. Okay. And then what about from the right?
Mirrored.
Same thing. Cool. Looks good to me. Right? Exactly like that first one was a great example of when the function's undefined and the limit doesn't exist because we're headed just not towards a real number. And I think it would have been also okay if we had, let's say, like gone down, towards negative infinity instead. That'll make it really, really not exist because we're heading in two totally different directions. Okay. Did anybody have a different style graph for that first one that maybe didn't have an asymptote? I think that's a great one. I think that's a great example. Any other thoughts on how to create a graph that maybe has a limit that does not exist and the function's undefined?
Could you just
Listening.
draw a line with a hole in it?
Okay, so I've got let's say put a hole up here, put a hole wherever, right? Okay, so what happens on the left side of that hole? Are we getting close to that spot?
Yeah.
Like, so I approach it this way, okay? Now the thing is if I want the limit not to exist, I better not approach the same hole from the right. So what are we doing on the right then?
And on the right, you have it go towards A in a different spot.
Okay, so if here's A, okay, so maybe our graph like heads down this way. Cool.
Yeah.
And if I want the function to still be undefined, then what are we heading towards if
Another hole.
Yeah, absolutely. Right? Just another hole somewhere else. That's great. Okay. As long as there's either a hole or an asymptote, the function's undefined. That's a great way to draw it. And if I want the limit to not exist, either just I approach the asymptote in any way that I want, and I'm all good, or we just approach two different holes. And I think that would work. Awesome. Love it. Great. What about for the one that does exist? Function's undefined, but the limit does exist. What has to be there? Can we have an asymptote?
No.
No, not if the limit exists. So what's the only other way for us to draw something that's undefined at A, but still has a limit?
It would have to be a hole, right?
Has to be, absolutely. And we have to approach it from both sides. Only way to do it. It's the only way to do it. That's the only way I can think. I'd be surprised if anybody that did that correctly did anything else besides draw a hole with our curve approaching it. Great, love it. Okay, cool. I like it. And if you can start to visualize these ideas, I think you'll start to really wrap your head around the limit really nicely. Because the limit is kind of the foundation, is that once we decided that we could get close to things but not actually get there, we could really kind of study the behavior of a function nearby and not worry so much about what happens when we get there, which is really nice. Right? And you'll see why when we get to chapter 2, even maybe chapter 1, second half of chapter 1. We'll see. Okay, cool. So what I would like to do is give you some time to just try it. Before we do any of the tables there on the bottom of page 16, I'd rather kind of keep our focus on the visual side of things and just go ahead and flip to page 17 and try those. Just take whatever time you need and try A through H there using the function that's up at the top. Okay, trying to get a handle on, okay, what do I do when I approach it from the left? How do I do it when I approach it from the right? If there is no plus or minus little superscript notation there to tell me that I'm coming from one side or the other, that means you're coming from both. And you want to kind of consider both sides if that limit is going to exist or not, right? So take some time, try it out. I'm going to scroll here so I can get to that. And I'll put up some answers, and if you get them right, then you're doing great. And if you don't, that's okay, but I would love to talk about like where you got confused, because you're probably not the only one. And then we'll be done. I'll kind of call that the day, and then we'll get to the table kind of thing. We'll get to the numerical kind of evaluating of limits tomorrow. To that. So I'll let you get out in front of me, and then I'll start writing down some solutions. My suggestion is to always put an equal sign after all of these. And to get used to saying these out loud. Or in your head. I just want you to be able to verbalize. I know it has C twice. It's not perfect. A, B, C, C, D, E, F, G, H. So it's really A through I. There's 9 of them. And I will slowly start to put them up one at a time. So there's the first one. And I know the copies might be a little bit blurry, so if you have to kind of count your boxes just to be sure you're going to the right X value, like I know like -5 and -6 kind of both look the same, so just be careful there.
My copy of in here, so the graphic doesn't show up. Could you like put the link into the to the PDF so I could look at it on my computer?
Yep, absolutely. There you go. And we're on page 17. Okay, there are the first 3, so check to make sure you got those right before you move on.
So where you put infinity, can we put does not exist?
Absolutely. Absolutely. Anytime there's an infinity, I will gladly take does not exist, because that is the truth. The limit does not exist. The only reason I could do it is because it was just from one side. If that was, as x approaches -3, right? Like this one down here, right? It says the limit of f of x as x approaches -3. I have to, because it's not one side. But yeah, you definitely can put does not exist for A, D, and E. Second row is done, so take a look when you're ready. Of course, feel free to work at your pace, though. And there's the last 3. And when you are good with those, I'm good. We'll end class a little early today. And we will pick this up tomorrow. Again, nothing you need to submit to me for today. Just come on back. And remember, tomorrow is Wednesday, so I think we're there a little bit earlier than usual. I think we'll be at 8:30 rather than 8:35. So just make sure you jump in on time so we can get some more work done with these links. Okay, but stick around as long as you need to check your answers to this. Make sure you're doing okay. If you got something wrong and you're not sure why, let's talk about it. Let's do that now so that when we get to tomorrow, this stuff is all cleared up and you're feeling really good about it.
Can you do the -5 limit, the top middle one?
Sure. Okay, so when I look at my graph, and they asked me to find the limit of f of x as x approaches -5. And there's no little plus or little minus sign up in the superscript, so I know that I have to approach it from both sides. And so that's what I kind of do, is I approach it from the left. So I just kind of like track my finger along there, and then I approach it from the right, and I can just kind of track my finger along there. What I see is at the point at -5, like if I actually go up to the function as it approaches, it looks like I'm approaching the hole that exists at -5, 4, right? There seems to be a hole right at that spot. Now, sure, yeah, there's a point at -5, 1. That's, f of -5 is 1, but I don't care about the points. I just care about what happens as I follow the function and get closer and closer and closer to it. And so I move along the function from the left, and I'm approaching the hole. And I move along the function from the right, and I'm approaching the same hole. And so if I'm headed towards the same location, from, I guess I'm going this way, right, from both sides, then that's what I want if I want my limit to exist. And I know that my fingers are never actually going to touch because I'm never actually going to reach the hole. But what I have is a y value that I'm getting closer and closer and closer to from both sides. And if I'm approaching the same y value from the left and from the right, then the limit exists. And it's just whatever that number is that we're getting close to. And that y value is 4. Does that make sense?
Yeah, thank you.
You're welcome. Okay, so for A and for H, infinity is great. Does not exist, of course, also great. The first one is a little bit easier because you're approaching an asymptote, but as we go towards infinity, right, as x goes towards infinity, you see the graph is kind of like pointed up and out forever with that arrow on the end. So that's where we're headed, up and out forever. So although there is a horizontal asymptote on the left that we're getting close to, we are not getting close to that horizontal asymptote on the right. And I think that's just due to the piecewise nature of the function itself, right? The graph on the left is kind of exponential or rational with the piece on the right, and then all of a sudden it stops and we have this absolute value function kind of take off because it's shaped like that. That V, it's got that sharp turn there. So that's okay, right? Horizontal asymptotes are there to guide us if that's where we're going, and not if we're not. That's okay. Any other questions?
Can you go over E?
E. Yes. Okay. So what E is asking is approaching 2 from the right hand side. And so let me go back to the graph if that's okay with you guys, so I can actually point at it. And so if I'm approaching 2 from the right, this is the direction I'm going to be coming from. And so, and you can see like I'm just a handful of boxes away as I do that. And then I follow the function as I get closer and closer to 2. And you can see that I have that arrow on the end as a guide, as a reminder of kind of remembering that the limit is where I'm headed. Wherever, like, I don't care about any other part of this function except what's in blue right now, kind of the few boxes that are leading me close to 2 from the right-hand side. And so when I do that, when I follow the function from the right, it looks like I'm aiming for that hole, and that the y value at that hole is 6. And remember, that's all the limit is the y value that we're getting closer and closer to as we approach whatever x value was given. So that's why my limit there is 6. Good?
Thanks, Rosie. Yeah.
Yeah. Any other questions? Okay. I'm good if you are. Feel free to take off. Nothing to do between now and tomorrow. I will just see you tomorrow, 8:30.
Mr. Rosengren, I showed up a little late today during class, so if you took attendance, do you think you
I
could
take attendance after the fact because
Oh.
I get an email that sends me the attendance record from when people logged on. So it'll let me know what time you got here.
Okay. See
Yeah.
you.
Thanks, Ethan.
Bye.
Thank you. Have a good day.
You're welcome. See ya.